Hello and welcome to Maths with El Profe Lo. In this video we're going to be doing some elementary number theory and specifically working with the Legendre symbol. Right? And remember that for the Legendre symbol what we have is we let P be an odd prime number and we let A be an integer such that P does not divide A, so P is not a divisor of A. Then this Legendre symbol, denoted with A and a vinculum P inside of these parentheses, is evaluated as the Legendre symbol of A modulo P equals 1 if A is quadratic residue modulo P, and it equals -1 if A is a quadratic non-residue modulo P. So in other words, this is a way of adjusting the notation and being able to compute whether or not A is a quadratic residue modulo P. Okay, so we have this proposition 4.5 that says that if P is an odd prime number and A and B are integers, with P not dividing A and P not dividing B, then A squared, the Legendre symbol of, and let's write this so we can see it a little bit better, the Legendre symbol of A squared modulo P will equal 1. Right? Because really what we're saying is there some number A, right, that will be a quadratic residue modulo P? And the answer to that is, well, yes, of course there is. Right? And that's because A squared is going to be our quadratic residue. Okay? Now, if A is, the next part to this proposition is that if A is congruent to B modulo P, then the Legendre symbol of A modulo P equals the Legendre symbol of B modulo P. So I can simplify things down using this relation. And proposition 4.5c says that if I have a product, right, if I have an A times a B, and I want to know, is that a quadratic residue modulo P, right? Well, then I can look at it as a product of two Legendre symbols. I can look at it as a product of the Legendre symbol A modulo P and the Legendre symbol B modulo P. So I can break things down. Okay. Now, additionally, we have this theorem that says that if P is an odd prime number, then the Legendre symbol of 2 modulo P will equal 1 if P is congruent to 1 or 7 mod 8, and it will equal -1 if P is congruent to 3 or 5 modulo 8. Right? So as an example, right, if P were equal to 7, clearly 7 is 7 modulo 8, so 2 would be a quadratic residue modulo 7. Right? However, if I had 5 as an example, right, if I had 5, where 5 is a remainder of 5 on division by 8, then 2 is not a quadratic residue modulo 5. And in fact, if I think of P as being 13, 13 is 5 more than 8, right? That 2 is not a quadratic residue modulo 13, and that's based on theorem 4.8. But let's go ahead and show this through a couple of practice problems. The first one is going to be to evaluate the Legendre symbol 96 modulo 11. Right, so let's look at that. Right, 96 modulo 11, and hence determine if 96 is a quadratic residue modulo 11. Okay, so I'm going to slide this up to look at these pieces right over here, and I'm going to start with C and with A. I'm going to start with C and with A and see if that can start to help me. And I'll say, okay, well, what is 96 divided by 4? 96 divided by 4 is 24. So what does that tell me? That tells me that the Legendre symbol of 96 modulo 11 will be equal to the Legendre symbol of 4 modulo 11 times the Legendre symbol of 24 modulo 11? Well, 4 is a perfect square. So what this is going to tell me is that this is going to be equal to 1 times the Legendre symbol of 24 modulo 11. Okay? Now, 24 we could break up further using proposition 4.5c, and we could say, hey, 24 really is just 2 times 12, right? So I could say that this then is equal to 2, the Legendre symbol of 2 modulo 11 times the Legendre symbol of 12 modulo 11. And of course, when we multiply by 1, right, well, that's just multiplication by 1. So now I'm at this point, okay? And fortunately for us, if we look at this first part, we have that 2 modulo 11, the Legendre symbol, is going to be given by theorem 4.8, and 12 modulo 11, the Legendre symbol, will be given by proposition 4.5b. All right? So, what can we say? By theorem 4.8, the Legendre symbol of 2 modulo 11 is going to be equal to something, right? And this is going to be based on, so we could say because 11 is congruent to 3 modulo 8, right? So 11 is congruent to 3 modulo 8, and that's the difficulty of theorem 4.8, is that we're working with modulo 8 rather than modulo 4, right? But we say that 11 is 3 modulo 8, so 2 would be a non-residue modulo 11, okay? So once again, P11 is prime. 2 modulo P will equal -1 if P is congruent to 3 or 5 modulo 8. 11 is congruent to 3 modulo 8, so therefore 2 is incongruent, is a quadratic, 2 is a quadratic non-residue of 11, modulo 11. Okay? Now, that's for 2 modulo 11, the Legendre symbol. What about for 12? All right? Well, by, not theorem, but rather by proposition 4.5b, 12, the Legendre symbol of 12 modulo 11 will equal 1, and that is because 12 is congruent to 1 modulo 11, and if 12 is congruent to 1 modulo 11, then we have 1 modulo P. All right, so let's write that down. That means that 12, the Legendre symbol of 1211 will be equal to the Legendre symbol of 111, and 1 is always a possible quadratic residue modulo P. Okay, so what does that tell us? That this is going to be -1 times 1, which is equal to 1. So therefore, 96 is a quadratic non-residue modulo 11. Okay, that's what we have. And of course, if you had Wolfram alpha or something similar, you could look up what are the quadratic residues modulo 11, right? And you might get yourself a list of these quadratic residues modulo 11, and you would be able to go in there and know that you're going to have 5 non-zero quadratic residues modulo 11, which happen to be 1, 3, 4, 5, and 9. And then we could say, okay, well, 96 minus 5 times 11, right, minus 3 times 11 gives us 8. That 96 is equivalent to 8 modulo 11, and we notice that 8 is a quadratic non-residue. So that's ways that we could go through and double check our work. So evaluating a Legendre symbol using some additional theorems and our propositions that can make things more quick to compute. Okay, we will do another example in a subsequent video. This has been Maths with El Profe Lo. I thank you for your time.